Welcome everybody here this evening. Thank you for showing an interest in the bats of Vermont. My name is Julie Filiberti, and I am a current board member of the Friends of Missisquoi National Wildlife Refuge, and we are bringing you this presentation tonight. So for those of you that have not been to visit the refuge up at Missisquoi before, we encourage you to do so. I'd like to tell you just a little bit about the refuge before we get started tonight. The main parcel of the refuge is located in the northwest corner of Vermont in the town of Swanton, and it was established 80 years ago in 1943 to provide a protected resting and feeding area for migrating waterfowl. It encompasses over 6,500 acres of land and water. In 2013, the refuge was designated a Ramsar wetland of international importance, and it is also an Audubon important bird area. A majority of the refuge is composed of wetlands and floodplain forest, where the Missisquoi River empties into Lake Champlain, the most expansive intact floodplain forest in the state of Vermont. The refuge also contains the largest bog in the Northeast, the 900-acre Mequon Bog. In addition to these expanses of unique habitat, the refuge also contains shrublands, and it maintains 250 acres of managed grasslands. The refuge is an essential resting and feeding stopover for migrating ducks and geese and shorebirds and other water birds. It's a haven for 17 different state threatened or endangered species, including the spiny softshell turtle, the black tern, and the recently threatened eastern meadowlark. There's also some property up north of Newport, the Eagle Point area that is managed by the Vermont Fish and Wildlife, but that is actually part of the Missisquoi Refuge. And they also have some land over in Westville, New York. But at the main parcel, we have 5 different trails that you can take a walk on. We have the entire length of the Missisquoi River that will go out into Lake Champlain that you can paddle on. So we encourage you to take a day and come up and visit if you haven't done so. And even if you have, come on back up and visit. Our Friends organization is dedicated to supporting the refuge, and one of the ways we do that is to bring public awareness to the refuge through presentations like this. And saying that when we have in-person presentations, it's easy to put out a donation jar. When we do online presentations, it's really great because we can increase the width of our audience and bring in people from all over the state as well as all over the country for that matter. But we can't put out a donation jar. So if you are so inclined, we encourage you to go ahead and visit our website at www.friendsofmissisquoi.org, and we have a donation button there. And if you, like all of us, would like to support the refuge on an ongoing basis, we would encourage you to join our friends group. There's different levels of participation that you can do that. And that's easy to do on our website also. So if you can, give your support. We like to be able to give these presentations free of cost for people, but it is getting more and more expensive for us to do so. So any donation helps. We don't do any fundraising. All the money that we get is through donations and through membership. So tonight's presentation is all about Vermont's bats. And if you are like most of the population, you probably don't particularly like them. You might be a little bit afraid of them, especially if one shows up inside your house. You're not sure what to do. Tonight, we are hosting Barry Genzlinger, and he's here to dispel all of the myths and the bad press that bats get. We're hoping that maybe by the end of his presentation, you will come to find them a little bit endearing. So before we do get started tonight, I would just like to honor the Abenaki by reading our land acknowledgement. The lands and waters of the Missisquoi National Wildlife Refuge are very special places to those who make it their home. And we, as the current stewards of this area, recognize our responsibilities in caring for these lands and waters. We recognize that these lands and waters are also important to the Abenaki Nation of Missisquoi, the previous caretakers of this land. We are grateful to them and their ancestors for caring for this land and its surrounding waters for thousands of years. We understand the importance of this land in the indigenous heritage of the region and to the Abenaki, present and past. We recognize the hardships and suffering these families endured when they were pushed out of their traditional ancestral lands as European colonization took hold, and we acknowledge their agony and despair when their access to the Delta for subsistence was ended by the creation of this wildlife refuge. We invite our visitors to share in honoring this Abenaki home by engaging in mindfulness while enjoying the refuge lands and waters, and by holding the space with care and appreciation. So with that, live from the Vermont Bat Center, I'd like to welcome Barry Genzlinger, and I will let him give a brief introduction of himself before he digs in. So welcome, Barry, and thank you for being here to share your knowledge with us tonight. You can take it away.
Why, thank you very much. So the first thing I want to point out is I love questions. I don't have any idea what you want to know, so I will be happy to answer questions throughout my presentation. If you can pop them into the chat and someone can monitor the chat and just bring those questions up. It's important for me to make sure you get your questions answered as we go along. Today is an interesting day here at the Vermont Bat Center. We have just taken out of our hibernation cave all the bats that we have in there, and those bats will have now been weighed and medically checked to make certain that they are still okay. Some have been in there since November, and we keep them in there in a hibernation area, just as if they were out in the wild, hibernating in the wild. I'll introduce you to one of our little friends. Over my shoulder, you see cages lined up, and the cages each contain a bat from a very specific area of Vermont. We have to keep track of every bat, where it came from, what the circumstances were, and in the springtime, we have to return that bat back where it came from. That's the law for any rehabber. So for those of you who have sent us a bat and said, this bat came from our kitchen, we found it in the kitchen, we're bringing it back to your kitchen. So get ready. Not really. So what I want to do is I just want to do an introduction to the bat species that we have here in Vermont. And I don't know whether any of you are familiar with the bat species from around the world, but I can give you a quick tour of some of the bat species around the world. It is an interesting fact to me every time I do one of these programs, and I've been doing these programs for 20 years. It's an interesting thing for me to realize there are more bat species on this planet than there are horses, cows, cats, and dogs combined. There are more than 1,400 different bat species on this planet, and they all do good things for our overall ecology. So, with that said, I'm going to share my screen, and I'm going to let you all jump in with questions as we go along. So I'm going to start with just a very quick tour of bats from around the world. And I trust everyone can see the screen that I have coming up any second now. There it is. So most people, when you say, oh, it's a bat, they think of these dark little things that fly around at night, and they're ugly and they're vicious. The reality is, bats are very gentle. This particular bat that we're looking at here, prior to 2006, which seems like ancient history, prior to 2006, this was the most plentiful bat in North America. There were millions and millions of them. In 2006, a fungus came along and it started killing bats just by getting on the bats. And I'll talk more about that in a little bit. So this bat went from 2006, the most plentiful bat in all of North America, to the endangered species list, which is, when you think about that, in that short period of time, we usually think of things reaching the endangered list over a period of many, 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 many years. But this guy, along with 4 of his buddies, all hit the endangered species list very quickly. So this is the typical view of a bat. But here is a little quick tour of some of the other bats from around the world. And I particularly like this picture. It highlights why scientists have given bats the order of all the bats of the world, the name Chiroptera. Chiroptera means hand wing. And if you look at this guy's wing, this girl's wing, this girl has a beautiful hand right here. And you can clearly identify the elbow, the wrist, and a thumb, and 1, 2, 3, 4 fingers. So when a bat wants to fly, it simply opens its hand, and its hand forms its wing. And bats are the only species that have fingers longer than their legs. If you look at this little stubby leg here, you can see these very long fingers that make up the bat's wing. This one is the smallest bat species on the planet. It's a little tiny thing. It weighs about the same amount as a paperclip. And then we have on the other end of the spectrum, the largest bat species. These are generally referred to as flying foxes, not because they're related to foxes, but because their face kind of looks like a fox face. But they are very gentle, very friendly, and they eat fruit. They are frugivores, and there are lots of species of frugivores. This is the face of a frugivore. He's got these kind of little ears and great big eyes. The big eyes allow him, in the low light, allow him to see a fruit tree and fly up to the fruit tree so he can grab a piece of fruit. So frugivores have smallish kind of ears and great big eyes. Insectivores, on the other hand, have small kind of eyes and very big ears because they are hunting for bugs. And as they fly around, they're looking for bugs in the environment in the dark. If you can picture yourself on a bicycle riding down a hill at 20 miles an hour on a bicycle with your eyes closed and trying to catch a mosquito as you go by. That's what these guys use their big ears for, because they can use that echolocation to track down where the bugs are. So here's one, big ears, little eyes, an insectivore, and it's got this funny thing that protrudes out of its nose. It's called a nose leaf, but we're not sure what they do with that nose leaf. We thought, initially scientists thought that must have something to do with their echolocation, but then they found that on fruit bats, which don't utilize their echolocation much. So another insectivore, big ears, little eyes. And another one, big ears, little eyes. Big ears, little eyes. These are all ones that can be identified as insectivores. So you see, bats are not all just of one type. They're not all those little dark colored things. And they come in a wide variety of shapes and sizes, from little tiny things up to great big things. Some of those frugivores have got 6-foot wingspans. This is a very interesting picture here. These bats are a pure white. They live underneath a palm leaf. And if you look closely, you can see along the spine of this palm leaf, they have chewed along the spine of the leaf, which has caused the leaf to fold down and form a little tent. And they can live underneath that little tent and stay perfectly dry. When the leaf finally dies and dries up, they just move to another leaf and chew the spine. The leaf folds down and they have another tent to live. Interesting one here called the wrinkle-faced bat. You see how clever scientists are naming these animals. Gotta love it. And for those of you who are familiar with the book Stella Luna, this is the fruit bat and child that Stella Luna was patterned after. Bats often will go out foraging for food and carry their little babies with them. And as you know from the story, Stella Luna wasn't paying attention and wasn't holding on and ended up on quite the adventure. If you haven't read the book, I don't want to spoil it. And here's a curious one. This bat goes for the nectar in flowers, and it has a very long tongue, which allow the bat to get its head in the flower and its tongue to go all the way down to the bottom of the flower where the nectar is, and it can use its tongue to lick up that nectar. This guy has a 3.5-inch long tongue, which is longer than its entire body. Kind of a curious thing. So there's a bit about the bats from around the world and the huge variations there are in their appearance and the way they interact with the environment. Along with that, let me just give you a quick thing of what kinds of things do all these bats from around the world eat. So here are some things that some of these you might know, some of you might not. But there are 750 or more insectivore species, and they eat moths, and they eat crickets, they eat grasshoppers, they eat anything that they can grab in the insect world, including things like centipedes, millipedes, or perhaps your delicious scorpion. So the insectivores eat a wide variety of insects for those insectivore species from around the planet. Then we have the frugivores. There are about 250 species of frugivores, and frugivores like eating fruit that we humans would consider overripe and squishy. But bats like overripe and squishy because it's easier for them to chew it up and eat it. So they will take a great big bite out of a piece of fruit and chew and chew and chew and get all of the juices and all the good stuff out of the fruit, and then they spit out the pulp that they don't like. So if you ever watch one of these shows about fruit bats that are being cared for in captivity because they've been injured in one way or another, you'll notice that they are all taking their fruit, eating it, and then spitting. So there's a constant, during feeding time, a constant rain of spit out pulp that they didn't want to eat. This little guy, I have a t-shirt with this guy's picture on it. He's called Figgy Piggy. He's got a mouthful of fig, and he's actually the first one that I showed that was right side up. The bats eat in an upside down position that we would say is upside down, but they consider this to be right side up for the way their body works. And a bat normally will go to a cluster of fruit. They will grab a piece of fruit. They will fly off with that piece of fruit to their favorite roosting spot where they will eat that fruit. But you'll notice they didn't take the pieces that are already completely rotten, like this piece here, these pieces over here, and they didn't take the piece that's green, hard, and ripe, ready for picking. They took the one that was just slightly beyond ripe, and they're taking off with that one to go have a good meal. So that's the frugivores. Then we have the nectar-eating bats, bats that fly around, stick their head into plants to get at the nectar that's in the plant. And then while they are getting that nectar, flying up to these plants, diving headfirst into the plant, they end up getting their heads covered in pollen. And as they move from one flower to the next, they are actually pollinating all of these plants as they go. In this case, these bats were pollinating the agave and the saguaro cactus. They are the pollinators that for the past, I don't know, million years or so, have been pollinating those plants. And the plant opens its flower at night, which is when the bats come by to feed. Here's another one. You'll notice here, way up on the top of this is an arm of the flower. The nectar is down at the bottom. The pollen is on this little piece, and it rubs on the bat's back. So as the bat goes from one flower to another, it gets the pollen on its back and carries that to pollinate other plants. So those are the nectar-eating bats. Then we have carnivores. Yes, there really are carnivore bats. Bats that eat things like frogs and lizards. They will actually pick up snakes and eat the snake. But on the other hand, there's a snake that likes to eat bats. So it's kind of an even wash. You'll notice this guy has very sharp teeth, and he will grab this little frog and he will grind that frog up, eating bones and all. So then we have, this one might be a surprise to you. We have bats that eat fish. Now you'll wonder, how the heck does a bat catch a fish? And one would first think they go to Dick's Sporting Goods and get a little tiny bat fishing pole, but that's not the case. They use echolocation. And when a fish is swimming around in the water, the fish, when it breaks the surface, makes circles in the water, and the bat uses its echolocation to figure out where the fish is, and it can go zooming in. And if you look closely at the feet on this bat, his feet have very long toes and curved toenails that are shaped like fish hooks. And he swoops down, he drags his feet in the water and hooks that fish and flings it right up into his open mouth so he can continue flying, where he goes off to his favorite fish eating tree where he will eat that fish. So then we have our very last category here. We've covered everything that we could think of here. We've got insects, we got fruit, we got nectar, carnivores, fish. The last category, of course, is blood. There are actually 3 species of bats that feed on blood. Now, Hollywood would love us to believe that these vampire bats that feed on blood get that blood by zooming up and landing on our neck, or by zooming up to an animal and landing on it and sucking the blood out. But the reality is, vampire bats are opportunistic. They will find an animal that has already been wounded, and they can then fly up and land on that animal. For example, a cow that has an injury, they can fly up, land on the cow. The cow doesn't even notice that they're there, and they can lick the blood from that wound. Or they can sneak up on a chicken sleeping on a branch and they sneak up at on the chicken. They make a tiny little nip at the end of the chicken's toe, so gently that the chicken doesn't wake up. And when they get that little nip, a drop of blood comes out. And that the bat's saliva has an anticoagulant in it, which keeps the keeps the blood from coagulating. So that bat will stay there and lick until it's had its fill, generally about half a thimble full of blood. It will then fly away, and its friend there is not going to risk waking the chicken up by biting it again. He's just going to move over and continue licking. And once both bats have finished their blood meal, they fly away, and the next few drops of blood wash away the anticoagulant. The chicken never even wakes up, doesn't even know it was bit, and the next morning it flies away healthy. So, how do bats get a drink of water? A bat will fly down low across a water source. That could be a swimming pool. That could be a feeding trough in a cattle yard. That could be a stream or a lake. And they will fly down low across the water, stick out their tongue, and take a drink. And I always wondered, how the heck did the photographer get such an incredible picture? Because you got to be darn lucky to just catch that one shot. And the reality is, this photographer had cameras with electronic eyes set up all around this little water source. And when a bat flew by and broke all those electronic beams, all the cameras took a picture. And eventually, he got the perfect shot. So after they have scooped up some water, they just keep on flying. And hopefully they didn't get too close to the water, or it didn't have any big waves in it, and they didn't end up in the water, because then they have to swim to shore and climb out and shake off and then take off again. But usually that doesn't happen. So that's what bats eat, what bats drink. Now, let's get on to the bats we have here in Vermont. In Vermont, we have a total of 9 different species of bats. Out of those 1,400 and more species of bats, only 9 of them are found here in Vermont. And they are all insectivores. They all gobble up about 1,000 bugs an hour while they are out feeding. So these guys are out flying around, having a grand old time, catching bugs. And of course, there are many stories about, oh, we were outside and bats started attacking us. Well, actually, you were outside. There were bugs flying around you, and the bats were flying by close to you, not because they were interested in you, but because they were catching the bugs that were flying around you. And they are experts at that. They could care less about humans. They want those bugs. So we're going to take a look at each of these 9 species briefly so you can see the difference and the similarities. I have divided these into a couple of different groupings. The first grouping is going to be what we call house bats. So up on the top left-hand corner of this graphic, you'll see this is one of our house bats. It is the big brown bat. It's called the big brown bat because it's enormous. It's 3.5 inches tall. It weighs half an ounce. And we call it a house bat because it spends its summers in houses. Now, what does that mean? Summers in houses means it could be in a barn, a garage, a house type of structure. That could be a bat house. That could be the steeple of an old church. Any kind of a building like that, we would consider a house, and we would find house bats there. Where does it spend its winter? It spends its winter either in houses or caves, mostly in houses, but occasionally in caves. So we got all these different big brown bats that spend their summers in houses and their winters in caves. So they are doing quite well. The big brown bats are doing well. The little brown bats, on the other hand, here's a little brown bat. And for those not familiar with looking in detail at a bat, little brown bat, I'm going to go back one slide. Big brown bat. Big brown bat is brown with dark ears, dark markings, dark light. Ooh, little brown bat is brown with, wow, do they look similar? The difference is a little brown bat weighs 1/4 of an ounce and is only 2 inches tall. And it's on the endangered species list. Why is this one on the endangered species list and the big brown bat isn't? Look in the top left-hand corner. This is a house bat. It summers in houses. So it could be found in any kind of a structure, but look where it spends its winter. It's a cave hibernator. It goes into caves and spends its winter sleeping in the caves. Generally, they'll go in as soon as there are no more bugs for a food source. They'll go into the caves, and they come out of the caves when their body clock says, gee, I'm running out of fat reserve. Fat reserve and something that weighs 1/4 of an ounce. That's not a lot of fat reserve, but they make it through the winter. Their body clock says it's time to go out. They come out again and there's bugs. So they can get right to work eating bugs and get back to feeding. Now, when that fungus, the white nose fungus, first appeared in caves in a cave outside of Albany, New York, we had these bats that got this fungus growing on them because the fungus liked being in caves. And the question that took a while to answer is, how did the fungus suddenly appear in the cave outside of Albany, New York? And the answer is it came somehow from caves in Europe where the bats seemed to be immune, and those spores from that fungus ended up in a cave outside of Albany, New York. However it got there, we don't know. But once it got there, it was the perfect environment. And the fungus grew like crazy, got on the bats, and made the bats itch. So the bats were waking up during the hibernation period when they're supposed to be sleeping. They're waking up and scratching and itching, and then they go back to sleep. And then they wake up again, and they're scratching and itching, then they go back to sleep. They are burning up their fat way faster than they normally should. So they're burning up their fat reserve. And as they're burning up that fat reserve, their body clock says, wow, it must be springtime. I'm out of fat reserve and I'm thirsty. So they fly out of the cave and it's February and they freeze to death. That didn't just happen to 1 or 2 bats. That happened to millions of bats. So starting in 2006, that fungus was in 1 cave. In 2007, it was in 2 caves. In 2008, it was in 3 states. In 2009 and 10, 11, and it spread like a wildfire all the way across the country. So that every cave, every crevice in the rocks where that temperature is that perfect temperature for bats to hibernate, it's also the perfect temperature for that fungus. So now all of our caves have this fungus in them, and the bats that hibernate in those caves are impacted. So, little brown bat is on the endangered species list. Looks very similar to the big brown bat, but if you had it in your hand, you would say, ooh, this guy is really tiny. Then we have our little thing here is in the way. I can't read what that says. Is this the small-footed? No, this is the long-eared. No, small-footed. So this one, if you had this bat in hand and you were really looking closely at it, you would say, gee, this guy's got really tiny feet compared to those other guys. And that's why it's called a small-footed bat. It is a forest bat, which means we would not expect to find this bat in our attic, in our garage, in our bat house. We would not expect it to be in structures like that. These bats like living in the forest in the summer, so we call them forest bats. But look where it winters. It winters in caves. And because it's wintering in caves, it's getting that fungus on it. And with the fungus on it, it's waking up and then the whole routine. So this one's on the threatened list. Then we have another forest bat that spends its summer in the forest. You probably in your lifetime wouldn't ever see one of these unless you find one in the forest, but it winters in caves. So this long-eared bat winters in caves, summers in the forest. It's on the endangered list because it has been impacted by that fungus. Then we have the Indiana bat, a forest bat. It spends its time in the forest. It will spend its winter in caves. Every now and again, we find one of these Indiana bats in a structure. Very unusual, but has been known to happen. But most of them we will find in caves hibernating and in the forest in the summertime. But again, because it's a cave hibernator, it's on the endangered list. And the tricolor bat, again, we call it a forest bat. It summers in the forest, winters in caves. And now, the third category, we have 3 species of bats that migrate. They spend their summers in the forest, and then they migrate south. And they may migrate flying thousands of miles, all the way down to Tennessee they go a long, long way. And in the springtime, they will follow the bugs back as they come out going north, and they end up back in the same place that they were the year before. So they are migrating a long distance and coming back to the same location. So this guy, the silver hair bat, and then we have the red bat. The red bat ranges in color from a bright red to a rust color. But again, it's a migratory bat. It follows the bug south. And finally, our last species, the hoary bat. This is the biggest bat we have here in Vermont. So when you see a bat flying around at dusk or in the nighttime, and you say, boy, that guy looked as big as a bald eagle. Well, the biggest bat we have here weighs 1 ounce and is 4 inches tall. It has a 16-inch wingspan. So if you think of a 16-inch wingspan compared with a crow or any one of the other big birds that we are used to seeing, this guy is still tiny, tiny, tiny. So those are the 9 species.
Barry, you had a question come in about what the fungus looked like.
Good question. Let me jump right to this is the so this fungus gets on the bats, makes them wake up. They come out early. Some of them had enough food stored, so they were really fat when they went in there. They weighed 15 grams when they went into hibernation. They were huge fat things. And they had enough fat reserve. They made it all the way out of hibernation. So they came out, the fungus was still on them. And the fungus, which appeared as a white fuzz on the surface of their the body parts that had no hair. The nose had the white fungus growing on it because there's no hair on it. The forearms, part of the tail membrane. So these were all areas where the fungus appeared to us, but it was actually all over their body. And the fungus was actually growing on the wing surface and all. So I'm going to skip over all this, but show you this series of pictures. This bat came out of Aeolus Cave down in Dorset. You'll notice, if you look closely, this is the left and right wings. There's a little funny spot right here. There's a little funny spot over here, and on the other wing. You can see, when you look at this, the wings don't look 100% normal. So we got this bat on April 10th. This is the same bat on April 26th. 16 days later, look what has happened. The wing has fallen apart. Why did the wing fall apart in these bats? The wing fell apart because their immune system was trying to get that fungus, which was growing on their skin, trying to get that fungus off them. So their immune system is so reactive and so strong, it literally tore their own wings apart. So this bat on April 26th was at a point where previous to us seeing this bat, everybody said, well, they're euthanize it. They're never going to be able to fly. They're in pain. They're in misery. And we said, wait a minute. They can heal a wing from a torn wing in a matter of a week or two. Let's give them a chance. So here's the same bat on May 9th. And you see what has happened is the bat is now growing back all of the wing tissue that was falling apart a month before. And here's the same bat on the 30th. Look at the wing. Completely normal wing structure. It has regrown the entire wing membrane, and in June, this bat was released. Fully, completely healed, capable of flight. So that's what the fungus looks like. It's a fuzz that you can see on the hairless areas of the bats. But once they come out of hibernation, the active fungus dies when it gets above 72 degrees, but the membranes are still impacted by all those little dendrites from the fungus growing into the skin, and the bat attacks its own wings, so to speak. Did that answer that question?
Follow-up is are they developing immunity to the fungus?
There is no immunity to a fungus. Is there a way that we as humans can do something to kill off the fungus so it stops getting on the bats? Well, we got fungicides that'll kill any fungus. The problem is caves have got hundreds of different kinds of fungus that keep the environment in the cave healthy. It's just this one that we don't like. So we don't have any way of selectively killing one fungus. So we were for years trying to come up with how can we get the fungus off the bats or protect individual bats when they fly in and out of the cave. Trying to come up with these great ideas for trying to inoculate the bats when they flew in and out of caves. But then we realized, holy smokes, this fungus is in every rock crevice, in every rock outcropping, in slag piles. It's everywhere now. And it has spread all the way across the country. So trying to prevent it is virtually impossible. But we have noted that in some of the caves, the bats have figured out on their own, if they go to a different area of the cave where the temperature is too cold for the fungus, they don't get the fungus on them. So now we're thinking, geez, Mother Nature's got this figured out. Maybe that's what happened in Europe, where the bats don't get the fungus on them, even though the fungus is present in the caves. So we have a lot still to learn about white nose, about the fungus, about how it lives, why it gets on some bats, why when a big brown bat happens to hibernate in a cave and comes out, does it have no fungus? Is there something about the chemistry of the skin of a big brown compared to a little brown, long-eared, any one of the others? What's the difference? So we're still working on a lot of things that have to do with this crazy fungus.
Barry, when their wings deteriorate like that to get rid of the fungus, is that painful for them, or are there no nerves in the wing membrane part?
Well, there's lots of nerves in the wing membrane. There are lots of muscles in the wing membrane. They have to be able to, the wing is a solid wing. So in order for a bat to fly, it has to be able to manipulate that solid wing to turn and do all of these movements with it. Unlike a bird with its feathers, a bat has a solid wing, so it flies like an airplane. So there are nerves and muscles. It's got to be terribly painful. So when we get these bats in, we treat them with a 10% betadine solution, which an iodine solution, which immediately kills off any remnant of the fungus and allows them to start the healing process immediately. And we can then provide them with the best environment, which is temperatures very hot. We keep the temperature when we have one of these bats, the temperature in their enclosure is about 95 degrees. The humidity level is 98%. It's almost raining inside their little cage. That allows their wing membrane to stay moist, and it allows them to do the best job they can at healing those wings as quickly as they can.
Another question came up about why the bats in Europe were not as affected.
We think now we're going on speculation here because we don't know a lot about the bats in Europe and how long the fungus has been in those caves. Has it been in those caves for 50 years, 10,000 years, or 1,000,000 years? So we don't know, have the bats over time evolved to the point where they know we can't go to this area of this cave because it's not safe, and they go to this other area where there is no fungus. Don't know that. So we still have a lot of things to learn, and there's research going on every year still with about white nose. Let me give you a quick thing if my internet pops right up here. This is the coolest little video, or not video, animated map, I should say. So here's an animated map starting in 2006. The X is Albany, New York, ground zero. And as we go along, here's 2006, 2007. In 2008, you can see that 1X has now spread to multiple locations in 3 states. In 2009, and then 10. Look at how fast it's spreading. So this is fungus that is actively on the bats, killing bats. It is moving south. It is moving west and north from Albany. And now it's in Canada, and it's up in Maine and Nova Scotia. Notice where it isn't. It's not in Florida. It's not in Mississippi. It's not in the areas where the caves are too hot for the fungus. But look at how fast it is spreading. Here we're up to 2014. Remember, we started at 2006. Here we are, 2016, after 10 years, and bam, look at the West Coast. Somehow, it ended up going from the central United States all the way to the West Coast. And then, once it was out on the West Coast and headed into Canada, it just went crazy. So here we are, 2023, and the fungus is everywhere. So it has spread, and hopefully the bats are going to begin adjustments. And you'll see here, there are a couple of areas down in Texas where the largest colonies of bats in North America are located. Single colonies with 40 million, 30 million, 20 million bats at a time. And suddenly it's appeared down there. So it's one of those things that is a tough thing to predict. We're hoping that the bats will figure it out. Did that answer those questions?
I think so. Another one came in about, does the fungus impact other animals or humans?
No impact on humans. When we first discovered the fungus, I have some pictures of the scientists going in and trying to look at the bats that have been impacted by this fungus, and they are head to toe in complete hazmat suits, because we had no idea what this fungus was, no idea what was killing the bats. And that was for a period of years. When we took a bat in during that period of time here at the center, we had to be in complete gowns, disposable gowns, and that bat came in and everything that touched it had to be destroyed. So that was when we thought, oh, geez, we don't want to get this, whatever it is, and we don't want it to be spread all over the place. And over time, we figured out a lot about the fungus. So it's one of those things where it doesn't impact humans, doesn't impact any other species, because they don't have the right environment. Even if they're in the cave, they don't have the right environment on their own bodies to support the fungus. So no other animals or humans have been impacted.
There's a question about the estimated number of bats in Vermont.
The estimated number, well, let's see. In 2006, if you had asked me how many bats are in Aeolus Cave down in Dorset, I would have said approximately 250,000. Today, if you ask me how many bats are in there, I would say somewhere in the neighborhood of 20 to 25,000. That is the scenario for every place that we have studied. A cave up in Elizabethtown. There's a cave up there. Used to have 14,000 bats in it. Now it has 0. The fungus got in there and killed the entire population. So that's kind of the way it has happened throughout the state and throughout all of those other places where that fungus has ended up. I mean, it really has been quite devastating.
Would they recover on their own, or would they just, or do they need human intervention?
Well, if the bats figure out where to go in the cave so they don't get the fungus, or the bats are eating well enough and getting enough food that they can make it all the way through the winter and come out the other end, then let's assume that that is the case and they're all healthy. So now let's say we have 30,000 bats in Aeolus Cave. Half of those are female. Half of those are old enough to have a baby. Half of those will have a pup. Half of those pups will survive. So we've gone from 25 or 50,000 bats in the cave down to 5,000 that might produce a viable offspring. How long is it going to take to get back up to 250,000 for that cave? And that's the scenario for all of our cave dwelling bats everywhere. How long will it take to repopulate when the numbers have been impacted so dramatically? And the answer is we don't know yet. We do know little brown bats, one of the most severely impacted here in Vermont, have been studied very closely. There is a colony of bats down at Shelburne Farms in a big bat house down there, which pre-white nose fungus had about 450 bats living in that big bat house. That number went down to under 100 at the peak effect of the fungus. Now, that number in the same bat house, that number for that colony is back up in the range of 400 and climbing. So, over a period from 2008, when it was first found in Vermont, up till now, we've seen the drastic decline and now the increase again. So we're hopeful. I have put my gloves on because I want to introduce you to one of my little friends back here. We have 9 cages here with big brown bats in it. So this guy has been disturbed today. And he was disturbed because we had to take him out, weigh him, make sure he's still healthy, and put bands on him. So if you look, you will see this little fella has an official Vermont, get my finger out of the way, a Vermont Fish and Wildlife band, that little silver band right there. It says Vermont Fish and Wildlife, and then has a number on it that is unique to this bat. And because the numbers are so tiny, we can hardly see them, we also add On the other arm, we add, I don't know whether you can see this, he's not cooperating. We have a red chickadee band on his other arm that will stay on only while we have him here. And when we release him, that one comes off. So he only will have the official Vermont Fish and Wildlife band. And that will allow him easy identification when we are looking, because we will have more than one bat in a single enclosure. That'll make it easy for us to tell who's who. Now, I have here, for those that are hungry, I have here mealworms. There are 2,000 mealworms here if you want a little snack. We buy mealworms 2,000 at a time. And this guy loves mealworms. So we'll see if he's going to cooperate and chomp this mealworm up. Probably not. He's camera shy. But the thing I wanted to show you while I have him out, since he's already irritated with me. There's his wing. And this wing is healthy, doesn't have any unusual markings on it. The skin is pliable, very soft and supple. And his fur is very thick. And he's really annoyed because I made him drop his mealworm. So he will get, over the next several days, get good food, and then we will put him back into hibernation. We will check him once again, probably late February, to make sure that he and each one of his buddies here are healthy, that their weight is good. We want to make sure their weight stays up, and that they haven't developed any unusual problems during the course. We have one bat that we're watching that was caught by a cat. And when we got the bat in and fed it, it gained weight nicely. We originally thought this guy is very lethargic. He's probably going to be dead in a day or two. A week and a half later, he was still eating like crazy. The wound that he had, where the cat had ripped hair off his back and made a big abrasion across the back, healed up nicely. And now he's doing just fine. He's gained, he went from 11.5 grams up to 18 grams, which, if you think of going from 11 grams to 18 grams, that's like me eating enough Big Macs to go from 155 up to a 210. So that's a lot of excess weight for me, but for him, that's a good, healthy number. And he's looking good, and we don't think he's going to have any problems.
How many bats do you take in during the course of the year?
Last year, we took in 58, I think, was the count for 2023. Now we, at this point, starting in 2024, we already have 9. This is the time of year when we have a warm spell in the middle of winter. What are the bats supposed to be doing? All of the house bats that hibernate in houses are supposed to be sound asleep. So if they're hibernating in an attic in an old building, the warm weather comes along, temperature goes up to, I don't know, 45, 50, 55 degrees. The attic gets too warm. They move around. And while they're moving around, they end up crawling through these tiny little spaces and end up inside a house instead of being in the attic. And those are the ones that we end up with here. All of these 9 that we have here now came out of somebody's house. They were hanging around and ended up, instead of being in the attic or hibernating wherever they were hibernating, they ended up in the basement, in the kitchen, wherever. And the people got them to us, and we will care for them and then return them back where they came from, right back into the kitchen. No, not in the kitchen. General neighborhood. So over an average year, I think our highest year ever, we had 108 during the winter. And the average year, we probably have 40-ish.
All right, a couple sort of related questions about bats in the backyards, if it's a good sign to have them there, what can be done to promote them, and what kind of housing are they needing if people
Well,
want to house them?
those are great questions. If we look, I'm going to share my screen engine just briefly because we're going to look at some bat houses. Bat houses are pretty darn easy to build. Bat houses are essentially two pieces of wood separated by 3/4 of an inch, which happens to be the exact size of a piece of pine board. So you can take 2 sheets of plywood and take pine and run a pine board up across the top and down the other side, leave the bottom opened, put another piece on top of it. So you have a sandwich like this, and now you have a bat house. You can make it a very fancy bat house with bevel cedar siding on the front, air conditioning vent here at the bottom, little air conditioning on the side. You can make multiple 3/4 inch chambers that will house lots of bats. Or you can make weird shaped ones. Or a big, huge one. This happens to be the very bat house down at Shelburne Farms that has that colony of 400 plus bats in it now. They used to live in the attic of the inn, but they kept getting in guests' bedrooms and the guests didn't like it. I tried to convince the inn, charge them more. We don't put a bat in every room. Sheesh. But they didn't think that would go. Bat house can be just one simple thing with screens stapled to the back of it, 3/4 inch space. Or you can go nuts and build lots of them. Big ones, little ones. The general rule is a bat house should be at least 18 inches wide and 30 inches tall, with 3/4 inch spacing for those living chambers for the bats. And then put them up on away from the house, on the side of the house. They need to get between 8 and 10 hours of direct sunlight all summer because the bats like hot temperatures when they're sleeping. They like it to be 90 degrees, 95 degrees while they're sleeping. So if you look at this array of houses here, we were part of a study many years ago, and there are black houses, brown houses, gray houses. The bats went into the houses that were the appropriate temperature for the time of year. So in the dead of summer, when it was hot, 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 they went into those gray houses. But that was very rare. Most of the time, they were in those black houses because the sun warmed it up and it was just comfortable for them. And a bat house can be put out anywhere where you can get it up high enough. It needs to be high enough so predators won't catch the bats as they drop out of the bottom of the bat house. Bats are going to drop out of the bat house in an arc because they have solid wings. They need flight movement in order to fly. So they're going to drop out of here and make a curve. And if it's too close to the ground, a fox or a house cat will sit underneath it, wait for them to drop out and jump up and catch them. Some people make big, huge bat houses and put them up in really prime real estate. This is down at the end of the Crown Point Bridge. Ginormous bat houses, even ginormouser. This is a bat house down in Florida, in Gainesville, Florida. And it was home to 70,000 bats. There were so many bats in it that they didn't realize how much weight 70,000 bats would weigh, and it started making the inside fall out. So they had to build another bat house. So they didn't call it a bat house, they called it a bat barn so they could tell the two apart. And that one filled up, so they built another one. There are now 250,000 bats living in these three structures. And they go out every night They eat enormous amounts of bugs every night around the University of Florida. And their droppings are perfect for the agricultural department to use for fertilizer, because bat poop is the best fertilizer on the planet. I like this picture because it points out, when you see a bat fly by, how you can be deceived by the visual distortion. I took this picture. These are all little brown bats with 10-inch wingspans. But if you look at this guy right here, he sure looks like a mighty big bat. But he had just flown over my shoulder when I took the picture. These guys up here on the wall are the ones that give you a better picture of the size. They are tiny little things. Remember, those little brown bats weigh 1/4 of an ounce. They are little tiny things, and these are all the same species. So, this is the inside of that building. Down at Kingsland Bay State Park, we put up a great big bat house down there. And then another one in Colchester, hoping that some bats would move in. And guess what? No bats have gone into either one of those structures, which highlights the point that just because you put a bat house up, that does not mean bats are going to move in. All you can do is put up a properly designed bat house in a perfect location for the bats and hope the bats discover it on their way as they're flying around at night.
What about the bat houses through the winter? Does anything need to be done with them?
Bat houses in the winter are not occupied. Bats go inside the buildings that are nearby. If you happen to be driving through a city like Brattleboro, there are a number of old buildings there that are abandoned. They had a basement and 3 stories, and in their day, they were a great manufacturing facility. Now, if you go into the basement of those buildings, because they are below ground level, they are just like a cave. And you can find cave bats in those caves. Of course, you'll also find white nose fungus in there. So the bats are opportunistic. When they find a place they like, they will utilize it. But that doesn't mean that just because you put a bat house up, that big bat house down at Shelburne Farms went 5 years without a single bat in it. And the 6th year, all of a sudden, 200 bats showed up. Somebody put the word out on the bat internet and said, hey, that's a cool place over here.
Where did they live before the bat houses popped up, and how do people attract them to their yards, and where are good places to put the houses?
Well, if you think back before humans populated the United States area, North America, think back way back. All the bat species lived in big old trees. Now, today we think of a big tree as being one of those 100-year-old maple trees that's got like a 4-foot diameter base. Those, if you think back 1,000, 2,000, 3,000, those are tiny compared to the trees of old. And when those trees died, they became bat houses. They were huge. They were 100 feet tall. They were massive trees, and they started rotting and had perfect habitat for the bats. Then along came humans and cut all those down and built these buildings. And the bats said, what the heck, let's move in there. So the bats have been living in human-built structures for as long as we've been building them.
Can you talk briefly about the prevalence of rabies and how likely those are to be showing up at the house?
I have a statistic that I like to give out about rabies. It has to do with your lawnmower. You are 18 times more likely to be killed by your lawnmower than you are to get killed by bat rabies in Vermont. So The moral of that is stop mowing your lawn. Or don't worry about it because you're not going to get rabies from a bat. There are very, very few bats that are ever found in Vermont that have rabies. And generally, when a bat, rabies is a disease that affects the central nervous system. So the virus gets into the bat, it affects their nervous system, they lose the ability to fly, they lose the ability to make vocalizations, they are in enormous pain. They don't foam at the mouth the way a coyote or a wolf. We think of those animals when they get rabies, we see them frothing at the mouth because they can't swallow. Bats are very docile, lethargic. They fall to the ground. When we get a bat in that we suspect to have rabies, it's fairly clear when we put the bat in an enclosure and turn it on its back and it's unable to right itself. It doesn't have enough coordination to do that because of the impact on its nervous system. So in a relatively quick period of time, a bat that has the rabies virus in it is going to die. Now, they can get the rabies virus, and before it impacts their nervous system, they can be flying around in your house, hibernating in your attic, which is why whenever there is human exposure or a bat is found flying around in a room with a sleeping person, a child, and we don't know for sure whether there's been contact, we get the bat tested for rabies. And most of the time, the bat gets tested for rabies, it comes back negative, and everybody's happy. So you are much more likely to die from a wide variety of other things than you ever are from getting rabies from the bat. Less than 1% of the bat that are found in Vermont have rabies. And 99% of those are never found by humans. They are flying around and they fall to the ground and they die.
Has any research been done to, I mean, the insect population is not what it used to be. Is there any research that's being done as far as the bats being impacted by the lack of flying insects?
Bats adapt to what food source is available. So if 5 years ago there was a plethora of moths and that's what they ate, they are now eating mosquitoes, no-see-ums, any other thing. If it's an insect that flies from dusk to dawn, that's the target bats go after wherever they happen to be. So those insectivores go after any of the insects that are available, and they'll adapt their diet based on it. The big problem that I am aware of, and I do everything I can to convince people to stop trying to spray for bugs. If you take a place that's got lots of mosquitoes and you say, geez, we're going to get somebody to come in here and spray everywhere around here to kill these damn mosquitoes because they're driving away the tourists and causing all kinds of problems. So we spray it and get it on the leaves. We're trying to kill the mosquitoes, right? So we get it on the leaves, we get it on every bug, we get it everywhere. And the bats, along with the birds and a bunch of other things, eat the bugs. Well, when the bats eat the bugs that have whatever the toxic spray is, then the bats are impacted and they end up being the ones that they aren't getting enough food, so they go into their hibernation areas and they're underweight and the fungus causes problems. So spraying for bugs isn't the solution. Putting up bat houses and getting more bats is the solution. They will take care of the bugs. If they're eating 1,000 bugs an hour and you put up a bat house and get 50 or 60 bats in your neighborhood, jeepers, that's a lot of bugs they consume every night. So I'm an advocate for no spraying.
Another question came up about what sounds they make and if they can be identified by sound.
Yes. Bats make two kinds of vocalizations. One is a vocalization that we humans can hear. They quite literally talk to each other. There's a lady down in Texas, Amanda Lawler, that for the past, I don't know, 30 or 40 years has been studying bat vocalizations. She has a huge number of non-releasable bats, and she can identify what those bats are saying to each other. She's been studying it that long, and they have more than 100 different vocalizations that they talk to each other with. Things like, "That's my food dish, get away," or "That's my girl." But, you know, they have all of these things that they say to one another. So that's one kind of vocalization that we as humans can hear. Then there's this whole other kind of vocalizations that all the bat species on the planet are capable of that we call echolocation. They make high-pitched sounds. They go out and bounce off their environment, come back to those big ears or small ears or whatever ears they have, and they can identify everything in their environment. That's the kind of vocalization that we can't hear, but the bats depend on to catch their food source, whatever that may be. And they can tell the difference between a gnat, a mosquito, and a moth. And they'll go after the bigger of the food source. They can even, flying around in a group of bats, listen for another bat's echolocation. And if it hits on a moth, another bat will try and steal the moth before the other one gets to it. So those are the two kinds of vocalizations. You can purchase a thing called the Echo Touch. It is a listening device that listens for the sounds that are out of our hearing range, which are all the bat vocalizations. Now, back in the old days, 20 years ago, when I started doing this, you could buy for $500 this little tiny thing that listened for sounds above our hearing range, but it didn't do any more than go beep, beep, beep when it heard one. Today, when you take one of those little Echo Touch meters and plug it into your iPhone, your iPad, your Android phone, you plug it in and it listens for those sounds and it will tell you that is the sound of a little brown bat, a big brown bat. It'll tell you the species of bat that you just heard fly by. Now, we didn't hear it with our ears, but the echo meter heard it, and it has a database in it with all of the bats from around the world, and they all make different echolocation sounds. Let me just pop one more thing up here, if I can. See if we can hear this. This is the sound of a bat while it is out hunting for food. And to us, this particular bat's echolocation sounds, that sounds like a bunch of screeches, but it's actually thousands of individual pulses going by so fast that our human's ears can't detect the individual pulse, but a bat's ears can. Here's another bat, totally different species, different echolocation sound, and you will hear the pulses have been slowed way down so that we can hear the individual pulses that the bat hears when it's at full speed. So listen to this. You'll hear the bat flying along. You'll hear the pulses going out, bump, ba-bump, 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 ba-bump. And when the bat hits on a bug that it wants to eat, the pulses increase, bump, ba-bump, 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 until it gets right up to the bug. And you'll hear what's called a feeding buzz. As it's getting very close, that buzz gets, the pulses get so fast, it goes bzzz. Listen to this. Got to listen really closely. Did you hear that little? Okay, here's a better one. This is the silverhair, one of the bats we have here in Vermont. You'll clearly hear it catch a bug. Got one. Got one. Got one. So those are the sounds that we as humans don't hear because they are above our hearing range. But with one of those little devices, those little devices, you should run right out and order one. You can get them on Amazon. They're only $400 or something. Everybody should have one. So those are the things that let us listen to the bats in our environment. And because we now have the capability of building these massive databases, it can listen, hear the sound, identify the species, and it even shows you a graph of what the image of the sounds looks like. They are very sophisticated now. I absolutely love them.
Okay, we would like to definitely thank you for all this information tonight, Barry. This was wonderful. Great pictures to see and great information. I don't know if you wanted to say anything about the Vermont Bat Center. I'm going to put the link to your website in the chat for people. I know that you accept donations. Is there anything you would like to say about the Vermont Bat Center? And
Absolutely.
okay.
Vermont Bat Center consists of two people, me and my wife. We have for 20 years been taking care of bats in Vermont. We are the only licensed rescuers for the whole state. We are desperately trying to find other people because when somebody from Bennington or Manchester calls us up and says, we have a bat, can you come get it? Well, actually, no, it's a 3.5-hour drive to get down to Manchester. How about if you bring it up? Oh, no, it's too far. And that's the end of the conversation. So we need bat rescuers to get licensed that will be in the southern, eastern, western part of the state, not just here where we are, because it's hard for some people to get bats to us. So we are always happy to take in donations. You can send checks. Our information is on our website and our Facebook page, vermontbatcenter.org and Vermont Bat Center on Facebook. And we're happy, but we don't require anybody to pay anything for any of our programs or anything else. We've been doing these free for 20 years. And it's our attempt to get the word out about the bats of Vermont.
Well, thank you for that. Thank you for
what-
everything that you've done for all of these years to save these little critters and doing a good thing. I hope you get some help to carry it on and make it easier for you.
Well, thank you all for coming. You were a fantastic audience with great questions.
I think that's it. So thank you.
Thank you.
Thanks for
Have a
joining.
great night, everybody.